So here are two last examples of detour proofs, similar to ones you may see in the homework or quizzes and tests, just to kind of give you the hang of it a little bit more. So in this second example, we're given that segment AB is congruent to segment DC, segment AD is congruent to segment BC, and angle 1 is congruent to angle 2. So based upon this given information, I want you to try to see if you can figure out which pair of triangles you have enough information to prove congruent, and then go ahead and take that detour first. We want to eventually prove that segment DE is congruent to segment BF. So then from there, I want you to see what you can do. Now keep in mind that as you're working through these proofs, there are multiple different ways to complete them. So just because I have one way of completing them doesn't necessarily mean that your way is incorrect. Okay, I'm only going to show you probably one example, but if you have questions, bring them to class and we'll discuss them. So pause the video now, try this proof, and then press play when you're ready to check your answer. Okay, so after looking over my givens, I found that I had enough information to prove the larger triangles congruent. So triangle ADB congruent to triangle CDB. Because I just had to use the reflexive property on DB, and then I could prove the large triangles by SSS. Then I decided that since I wanted to prove segment DE congruent to BF, that I needed to prove the triangles ADE congruent to triangle CBF. So I looked to see what corresponding side or angle those smaller triangles shared with the large one. Since we were already given that segment AD is congruent to segment BC, the only other thing that they had in common with the larger triangles were angles 3 and 4. So that's probably one of the most important parts of this proof, is this right here. Recognizing what corresponding side or angle those large triangles had in common with the two small ones. So once I got those angles congruent, I proved the smaller triangles congruent by angle side angle, and then I could reach my final conclusion by CPCTC. Okay, so let's take a look then at this last example we have of a detour proof. We're given that triangle ABC is isosceles with base BC, and that segment AE is perpendicular to BC. And you want to eventually be able to prove that angle BDE is congruent to angle CDE. So I'm going to go ahead, let you try this proof on your own, so pause the video here, see if you can determine which triangles you have enough information to prove congruent first, where do you need to take that detour in order to prove the final two angles congruent. So pause here, press play when you're ready to check your answer. Okay, so this proof was a little bit longer, this detour proof. Based upon the given information, I realized that I had enough information to prove triangle ABE congruent to triangle ACE. So here was my detour, proving the larger triangles congruent by HL. Because I had right angles, I could get the hypotenuses congruent and the legs congruent. Then I used BE congruent to EC because I noticed that they share that side with the large triangle, shares that side with the two bottom smaller triangles. And I knew I needed the bottom triangles congruent to eventually prove angles BDE congruent to angle CDE. So once I had those sides congruent, then don't forget, you still have to say in step 8 that angles 1 and 2 are congruent, because you don't need to say they're congruent in order to prove HL, but you do need to say it in order to prove the two smaller triangles congruent by SAS. So I used the reflexive property on DE. Finally, I got triangle BED congruent to triangle CED, and then I got my angles congruent by CPCTC. So hopefully now, after completing these 3 examples, you have a better idea of what a detour proof is and how to complete it. So always look to see which 2 triangles you have enough information to prove congruent first, and then you kind of go from there. Work your way backwards using what you're trying to prove to help you figure out the next set of triangles to prove congruent.